Hello and welcome to the online lecture, a very basic operating system theory. The point of this lecture is just to give you a very broad primer of operating systems theory. Obviously, you could spend a lot more time on this. In fact, if you go to a four-year university, you can spend an entire semester on it, or two actually. But the idea here is to understand the underlying concepts or theory of operating systems operations so that we can better understand the more complex concepts a little bit later on. So just providing a platform, if you will. So the very first question is, what is an operating system? Well, the point of an operating system is to control the hardware. Without an operating system, a computer is just simply plastic, metal, lots of silicon, but it's pretty useless, right? I mean, it's useful if you want to weigh down papers, if you want to hold the door open, but as for an actual device that computes, it will not compute. It needs software to control that hardware. And that's what an operating system does. It provides a platform, that's the term in the industry, a platform in which users can control and interact with the hardware. So when I say hardware, what am I referring to? Well, there's four components we're primarily going to talk about here on the very basic level. We have the processor, CPU. The quick definition of a CPU would be it executes lines of code. It has two parts. There's a control unit and there's a arithmetic and logic unit on the motherboard here. And you don't worry about all this stuff going on the motherboard here. I'm just giving you a real-world example of what a motherboard might look like, okay? To let you know the stuff, to tie it back to the real world, all right? This would be the processors here, okay? And logically or theoretically what we're talking about when we talk about a CPU, okay? And we're going to keep coming back to this because we're going to have to talk about dual threading, we're going to have to talk about multi-cores, we're going to have to talk about lots of things about processors. But for now, just know that a CPU, a processor, has two components primarily. We have the control unit, right, and we're going to have the actual CPU, the actual arithmetic unit. Excuse me, the arithmetic unit. Okay, arithmetic and logic. Okay, now when I say logic, it's because processors also perform logic functions, Boolean logic. If or and also comparative, greater than, less than, that kind of stuff. That's the type of logic we're talking about. All right. So that's the core of an operating system. Okay. There's also memory, or as we call it, working memory, or RAM, as it's sometimes called. In the case of this motherboard, the RAM is right here, well, at least the DIMM slots, the slots that put the RAM, are in there. There's no RAM on this motherboard as it stands right now. Essentially, memory are going to be small chips. It's primarily made up of small chips, lots of them, and those small chips either hold an electric charge, so it has an electric charge, or it does not have an electric charge, ones or zeros. We'll talk about bits and bytes a little bit later. The other important concept here with memory is if we were to turn this motherboard around and trace the lines, we would see that memory has lots of pathways to the CPU. And that's because it's really fast. It's really close to the processor, because the processor is going to use it as working memory. Think of it as your work desk, right? Your desk that you have in your office that you sit in front of all day. And you have stuff in there that, and you have items on there. You might have tools if you're a craftsman or workman. You might have your computer. You might have various other expensive things that at the end of the day you're going to lock up in a storage cabinet. The storage cabinet is going to be storage, okay? Memory is your working desk, the stuff that you have out at the time. And that's what processor does. Processor interacts with the memory, right? It's going to keep working with the memory. It's putting the variables there. It's going to pick the variables back up, right? We're going to talk about that a little bit. The hard and fast definition for memory would be provides a working retainer of data for the processor. Another key component too, it is volatile. What do I mean by when I say it's volatile? Well, it's subject to change, but in the sense of power, if this motherboard loses power, that memory, all the data in that memory, all those ones, well, particularly all the ones, All the charges that are being held by the memory, the chips, the memory chips, would get wiped out. They'd all become zeros, and that data is gone. Okay, so it does not retain data if you lose power. All right, that's the big thing about memory. Storage. So storage is where we keep things in the long term. Why do we keep them there in the long term? Here on this motherboard, the actual hard drive is, I got an ATA RAID card. That's exciting. There you go. And then we have a primary ATA IDE controller right here. All right, so this is going to be the where hard drives access. Okay, there's two types of hard drives. We have the platters, right? We have the spinning platters, which we'll talk about. You know, where it's going to have these metal discs that spin around. Now, the way this works is it uses, in the case of the discs, it's going to use magnetic properties of the disk. Or if you have a floppy drive, it's going to use magnetic properties of that floppy drive. Anything magnetic will just change the property. If it has one magnetic property, it's a 1. If it doesn't have that magnetic property, it's a 0. There you go, 1s and 0s. It's always going to come back down to 1s and 0s, right? So storage, the big thing about storage is it's non-volatile. What do I mean by when I say it's non-volatile? In other words, if the power goes out in this motherboard, the storage will retain its data. Okay. So the hard fast definition is storage is long-term, non-volatile retainer of data. And finally, we got peripherals. Usually it's input and output. This is the other devices: a mouse, keyboard, monitor, webcams, scanners, whatever, what have you. Network cards, actually big graphic cards, also very important. But for now, it's kind of on the edge because these three things are critical to an operating system. Okay, this is what the operating system's primary function is to do, is to control these three things. If we don't control these three things, then we're in serious trouble. Particularly these two things, processor and memory, right? And what we're going to see with the processor is we have that control unit, and we're going to have the arithmetic and logic circuit, right, or circuits. And what's going to happen is data is going to come in, and we tend to call these threads, okay? And these threads are going to come in, and this thing kind of spins. It has a frequency. That's why we measure processes and frequencies. You can call them also ticks, clock cycles, various things. Think of it as just a big spinning flywheel that takes these threads in, right? And then it's going to execute commands. And when I say commands, I'm talking about machine language, you know, halt and catch fire, various other commands that processors can do. And it's going to, you know, add that kind of thing, right? And it's going to take this data and it's going to do the math it needs to do, and it's going to spit it out, right? And so we have our input, right? And we're going to have our output, okay? So that needs to be managed, and that's what the operating system does. Also the memory, right? The memory, if I just draw a rudimentary, you know, stick of RAM, the memory is going to have like a grid-like system on it, okay? Very rudimentary, but there you go. It has to manage that grid. It's going to be constantly read to and deleted, changed, read, changed, cleared. All that's going to happen thousands of transactions per second, okay? Tens of thousands of transactions per second, right? It's going to make all these changes to the various sectors on the memory. All that needs to get managed by the operating system. And it's critical because what we're going to actually see is part of this memory is going to be blocked off. Say, hey, this is for the operating system, because the operating system itself runs in the memory. Yeah, it needs to run in the memory, right? It's a program, so it needs to run in the memory, and it goes to the processor and it does its things. But we need to reserve that part of the memory. We can't allow any other program like malware to get in there to make changes. You shouldn't be changing the operating, you know, the fundamentals of an operating system from the actual applications you're running on a machine. So the operating system needs to protect itself. It builds a hard wall around that memory, which is easier said than done, actually. And matter of fact, if you have a program that gobbles up more and more memory, okay, what ends up happening is, and it starts eating into the operating system. That's most of the time what a blue screen of death is. Okay, for folks that know that in Windows terminology, you get this big blue screen with some writing, usually about a memory location, and it crashes the entire operating system unceremoniously, or just rips because what happened is the rug gets ripped out of the operating system. It's part of its memory that's using, part of the desk it's using. Some other person just came in and started plopping their papers all over the stuff. It can't do work anymore. It has to throw its hands up and says, "I give up. I can't get to it." So that would be another critical function of the operating system is memory management. Another important concept is to know that operating system needs a processor, right? And it needs some kind of memory to work off of, okay? Ideally, if it wants to be fast, it's going to be working like RAM memory, right? Where it has that high transactional speed, right? It doesn't necessarily need storage. Matter of fact, you could load up the operating system or program your own operating system if you booted up a PC that or booted up a device that only had a processor or memory. You could just program your own operating system every single time. Obviously, that's not ideal, and the way it works is an operating system by default lives on the storage, and then what happens is when it boots up, it then puts itself into memory, right? And that way it can start processing and loading up other applications and that kind of thing. All right. So what actually does that? Let's move on to the next thing. All right. Actually, I kind of stepped on my own. So this is kind of what I was just doing there. Here's memory. Okay. As you see, it's got 4 arrows. It's a lot of transactions going on. But also think of this as a highway, right? This is a 4-lane highway, right? It's pretty fast, okay? As compared to, and there you go, there's a control unit, there's the arithmetic and logic unit. Storage, which is kind of like a dirt country road in comparison to memory. It's much slower. And that's going to play a big role later on. We'll talk about that as the course rolls along. But this is a big deal, okay? The fact that storage is a lot slower access time than memory. Part of it is if you have storage like platter drives, they're going to be slower anyway. You actually have a head moving over a metal platter looking at magnetic properties. It takes time. But even if you have a fast storage device like modern SSD hard drives, solid state hard drives, even then the interface going into the motherboard is very limited. Okay, it's still going on that two lane or that country road, right? That old country road. So keep that in mind. All right. As you can see, input and output are a key component of the operating system. Sorry, I jumped. So I was bringing up my draw tools and I accidentally switched over to my desktop. So if you input and output are a key component of operating systems. There's an old acronym around IT that I think is still important nowadays. So an important concept is garbage in, garbage out. All right. What that means is if you have garbage input, there's not much the computer can do about it. You're going to get garbage output, right? The computer isn't a miracle device. It can't make assumptions. It can't perform magic for you. If you give it garbage input, you're going to get garbage output. All right. As a matter of fact, most people who blame computers for their problems, it turns out it was garbage input. It was the user's fault, right? The user told it to do something that was stupid, and it did something stupid, and then they yelled at the computer for doing something stupid. So keep that in mind, especially if I'm trying to help you out in a lab and you yell at the operating system that it keeps messing up, because I'm going to say, any good technician will tell you it's probably you. Okay. Obviously, if you're answering help desk or you're working in a environment, you can't just go around yelling at users they're all idiots. But you do have to kind of know in the back of your head that that's probably what's going on, is the user told the computer to do the wrong thing, and now we're angry at the computer for doing the wrong thing. All right, so we have garbage in, garbage out, important concept. Input and output are a big deal. That's what the process is here. We have input. The CPU is going to interact with memory to work on it. It might output it to storage and save it in storage. It might just simply put it onto the screen. Depends on what the data is. If it's a cat video, right, it's going to download it from the internet. It's going to process the ones and zeros into a cat doing something silly or fun or whatever else. So there you go. Now, getting back to another key issue that I was getting to prior was the initialization. Bootstrapping, as it's called in the industry, right? How do we actually load the operating system from storage into the memory, okay? And that's where we come into two different options here. We have BIOS or UEFI. BIOS is an older system. Well, both of them run from a ROM, actually EEPROM chips. A ROM chip is a chip that's on the motherboard. That's actually, if we go back to that drawing on the motherboard, here's the battery right there. It actually has a little battery on the motherboard, and what that battery does is it provides power, and that memory chip cannot be written to. A ROM chip cannot be written to. A pure ROM chip cannot be written to, and it gets power from battery, therefore it keeps the data, so that makes it non-volatile, and we can keep either the older systems of BIOS, a newer system, UEFI. Nowadays, we actually have EEPROM chips, electronically erasable, programmable, read-only memory. The reason why we have those is so we can flash our firmware. That's why it's actually called firmware, firmware interface. It's not software because it's it's in a pretty non-volatile situation, so that's what makes it firmware. If you do have to flash your BIOS or now flash your UEFI, I don't know what the terminology will be that for, or maybe it is just flash your UEFI. I'm so used to saying flash BIOS. A lot of old techs still will call UEFI BIOS, so be advised about that. But BIOS stands for Basic Input-Output System. UEFI is Unified Extensible Firmware Interface. All right. Again, it initializes the hardware. It actually reads when it first comes up. It's going to say, "Hey, cool, I got a keyboard." UEFI will actually say, "Hey, I got a mouse." Not all UEFIs now do mice, but it could possibly support a mouse. It's going to look at the output, like the screen itself, right? It can look for, and it can look at different hardware. It's going to start spinning up, give power to the processor, bring the processor online, get the memory, get some basic memory organized, start spinning up the hard drives. Then it loads the operating system from what we call the boot sector from the storage. There's going to be a special sector on the storage. We'll talk about that later when we talk about storage management. But it's going to load the operating system from the boot sector into memory. All right. Now, you're going to say, well, hold on. You say there's BIOS and UEFI. What's the difference? Why is there two different things? Well, as I said, BIOS is older. Much older, actually. It goes way back to the 80s. It worked well, and it's a simple system, and simplicity sometimes is genius. And it's been around a long time, but limitations are starting to catch up. One of the big limitations we had was it stuck to, you could say 2 terabytes. Some sources will say 2.1 terabytes. But it's, of course, when they first came out with BIOS, that was rather impressive. People back in the 80s weren't probably thinking that dealing with terabyte drives would be a problem. But we're only talking about the boot drive, by the way. But your boot drive could only be it would only recognize 2.1 terabytes of data, no matter how big your hard drive was. Right? This says 2 terabytes, 2.1 if you ask some people. So BIOS can only handle 2 terabytes. All right. It uses what's called MBR to record where the boot sectors are, what part of the hard drive to look for the operating system. That's short for master boot record. All right. And that's all I really want to say about BIOS. I'm going to give a little demo to show you what the two of them look like and to get you a little bit familiarized with operating systems of VMware. UEFI in comparison, real quick, I'm just going to go over what it does. UEFI is obviously newer. It's very modular. This says it requires an ESP, which is a UEFI system partition. I've seen sources that say it's not required, so that's debatable. But that's a part of the hard drive that's been reserved for the purpose of UEFI to operate out of storage or something. It is CPU independent. Can handle drives larger than 2 terabytes. Actually can handle drives 8 zettabytes, which is huge, 1,000 to the 7th power. It can handle, again, but back in the 80s people said 2 terabytes, that's insane. Now we're saying 8 zettabytes, that's insane. Welcome to computers. But it can handle 8 zettabytes. It can have an ESP, which is a system partition for the purpose UEFI. It can have apps that are part of it, so it can do other things other than just bootstrap a system. One thing it can do is scan the operating system for changed files. It can check the files of an operating, the core kernel being in particular, but in the case of Windows, DLLs, system files. It can take a look at those system files and make sure that those system files haven't been changed or changed by malware. So it's a good thing. So that's one beneficial feature. UEFI. So let's give a quick demonstration of the two. If I bring up my VMware, there it is. As you see, I have my old operating system from CIT 120. What I'm going to do is change some things. So if I go into the file folder, I'm going to just show you this real quick. This is the actual virtual machine. As you can see, the hard drive split into multiple drives. This is the actual settings of the actual operating system. Okay, I'll bring up my good friend Notepad++. I'm going to do a new file. So here's my new file. Okay, I'm going to bring up Notepad++, and if I grab this and put it over here, all right, these are all the settings of my virtual machine. As you can see right off the bat, firmware, it was set to EFI mode. All right, if I change this to BIOS and I wanted to boot BIOS, so again, this would be decided by the motherboard too. What if you run BIOS or EFI? It depends on the motherboard. Okay, so in the case of a virtual machine, the motherboard is software, right? It's a piece of software that pretends it's hardware. So I'm going to change this to say your BIOS now, abracadabra. But then these are all the settings on my virtual machine, right? So shared folders. Again, I'm constantly playing with things, so you're going to see some weird settings in here. But you're going to see like these are PCI bridges and various SATA drives, and this is everything. These are the settings that simulate the hard drive, the hardware. The other thing I want to do is put in a command that's going to force it to go to BIOS, because I could hit F2, it's F2 to get in there, but then I have to get focused and hit F2, it's kind of difficult. So if we cheat a little bit and we put in an actual command, this is a one-time command and you'll actually see it go away. As a matter of fact, for fun, I'm just going to slam this over here. We'll talk about these settings later on. I don't want anything else there. And then I'm going to minimize this. And I'm going to bring up my virtual machine. What's going to happen is this one-time saying, and then it deletes this setting. Okay, but this temporarily says. So I need to save it. Now it's on my hard drive. And now I'm going to boot, because before that it was in memory. There you go. Until I save it, now it's on storage. And when this comes up, it's going to read those settings from the hard drive. So if I click on Play Virtual Machine, what's going to happen is it's going to tell it to do BIOS. That's what that does up there. And it's going to say, hey, go to BIOS. Okay, it's just like hitting F2. If, a lot of HP machines do F2. I think so do Dell's. Anyway, it depends on your individual device. Usually it'll tell you when it first boots up how to get into either BIOS or UEFI. But I'll show you the difference real quick. All right, so this is going to force it to go into BIOS. So I'm going to hit play. Oh, excuse me. And that's because I copied it over. It's from a backup. There it is. There's BIOS. Pretty BIOS, right? It's not going to Windows. Windows is installed on this system. But what happens is, all right, go away. I'm aware. All right. So what happens is this is BIOS. And this hasn't changed since I started playing with computers back in the late 80s. That's when I started playing. It's been around since the 80s, early 80s. Okay, this is your boot order, right? I'm telling it to boot off removable drives first, then my CD-ROM, so forth and so forth. And actually, this is the actual primary way to boot in the operating system. Most of you on your virtual machines are going to be UEFI. Slowly, we've been migrating to UEFI. As a matter of fact, the default is going to be UEFI starting 2020 from Intel. So you're going to see BIOS go away, but we still like it. So anyway, so this is setting. Now these settings are actually kept somewhere else. a different part of memory. And what will happen is if that that's also served by a battery. If that battery goes down, you might end up with that weird code that says, hey, by the way, system time is off, because it can't remember what time it is because it doesn't have the settings. Or you won't be able to change your settings and keep your it always go back to the defaults because it can't save the settings. All right. Anyway, so that's BIOS. That's what BIOS looks like. We're going to exit discarding changes. Oh, by the way, there's nothing but a keyboard here. You can't even have them. And the mouse is not even an option. Okay, UEFI mouse is an option, but you often don't. Discard changes, yes. Oh, anyway, exit discarding changes. There I am. Oh, I'm going to start booting the Windows. But before that happens, I'm going to crash my system. It's an old OS. I don't have to worry about corrupting it. All right, there it is. Now this is a pop-up from actually from Notepad++ saying, "Hey, we noticed this file has changed. Do you want us to reload it?" I just say yes. Boop, it goes away, right? And that makes sense because it's booted one time. So let me go back over to this, and I'll change this back to EFI for whatever reason they call it EFI, not UEFI. And I'm going to put that code on the bottom so it forces it to boot in there. Although UEFI will go automatically there. I'm going to hit save, and let's go back into VMware. Come on. And we're going to double click on my CIT110. Again, it's going to read from that file. It's going to want admin privileges because I copied over the operating system from a backup, so it gets a little weird. And there you go. There's UEFI, who actually has a different resolution, so I need to open this window up a little bit. There's UEFI. Okay, remind you later. I have VMware tools installed. Again, the keyboard's only what works here, but I can go in and I can enter setup. I can change drivers around. I can add a boot option. All right, boot option would say, let me give you an actual location on the hard drive. Right. By default, by the way, this is all. Now this isn't going to work because I don't have a GPT, so this is not going to work. Which is something I should mention, by the way. UEFI uses GPT, which is short for GUID. It's an acronym within an acronym. GUID, which is Globally Unique Identifier Partition Table. So it uses GUID codes, which is a hexadecimal character set. We'll talk about that down the road. But it uses a GPT to record where locations are. Anyway, so I don't have, in this case, if I did this, it's actually going to look over the network, in this case over IPv4, look for an operating system. It's going to fail because it can't find an operating system. Anyway, that's UEFI, all right? And it's actually operating off a bit of a partition that's part of the hard drive, all right? And we'll talk about partitions later on too. So this is got a little advanced and deep, but I just wanted to let you see what the difference is, okay? All right, so let me kill this. Yeah, you gave up, and I'm going to shut you down. All right, and again, this is going to say, hey, I noticed a change. I'm going to hit yes. Boom, it goes away. All right, there I am. Okay. Yeah, so UEFI uses GPT to boot up. So UEFI initializes the firmware and the hardware, for that matter. Displays UEFI shell options from ESP. That's what we had there on the blue screen. And then if we hit enter, it can load the operating system from storage and get the operating system. All this is going to give us a pretty picture for our user. All right. The whole point of an operating system is to make the user happy, so the user can control hardware. All right. So what is the user? Well, it's the greatest point of failure. I talked about that a little bit earlier. The longer you work in IT, the more you'll understand that the user tends to be the primary point of failure, which is not a terrible thing. And you shouldn't get angry about that, but you need to understand that as a technician. They're incredibly variable. It's really hard to guess what they're going to do. They could be flat out malicious. A lot of times they are malicious. They actually try to break things. Again, garbage in, garbage out. If you get bad data, you're going to give out bad data. And the user is the origin of data, and they're also the endpoint of all data, right? The whole point is for a user to receive data and do something with that data. Part of that is the user is going to use an application. All right, an application is a set of instructions that possibly loads from storage and runs from memory. Okay, so again, we're gonna install, like when Word first boots up, when you first load up Word or Chrome for that matter. If you notice, it takes a little bit longer than if you just minimize it, remaximize it, and that's because it's loading those instructions from the hard drive to memory. And again, the hard drive or storage is on that that dirt country road. It's slow. It takes time to get from point A to point B as compared to memory, which is on that 8-lane highway, right? Or 4-lane highway. I'm gonna have to settle on some picture, but that highway system, okay, a multi-lane highway system. All right, it takes more time to get loaded up from storage. So that initial running of the application is that's what's going on. It's loading up from storage going into memory. All right. What's the application do? It takes an input, it gives output to either the user or storage or both, right? As we just saw right there, my good friend Notepad++, right? It kept things in memory, and then when I told it to save, it put it in storage, right? Does not directly interact with hardware. What an application does, and we're going to see this with the application architecture when we talk about that, is the way the operating system is set up, the application runs on the platform. Again, we're going to go back to that term of platform, and you're going to hear that throughout your IT career. That what's your platform? What platform does this run on? Is this multi-platform? Right? Platform is your operating system, right? The platform, it can be other things too, but we're also talking about operating system. It provides a platform, it provides an interface for that application to run on. Okay, and what happens is the user, and there's the application, the user is going to interact with the application, which then interacts with the operating system. The operating system is then going to do what the hardware needs to do, and it's going to go back up the ladder, right? So it's going to go down from the user, application, hardware, back up. Think about it this way. If I run Skype, here I am as the user, I bring up Skype, I log in with my thing, right? And I'm interacting with the application. The application is running in the operating system. We'll talk about the software architecture of the operating system a little bit later. And then what's going to happen is that operating system is going to interact with the hardware, okay? And that hardware could be the webcam. I just moved my mouse up here because my webcam is above my screen, right? That webcam is going to be what loads up or the picture that it sends over the internet, which it sends it through the operating system, through drivers and various other things. We'll talk about that with hardware infrastructure as well. And it goes up through the application, and the user gets to see the picture from afar, and you get to see your picture as well, right? So that's the circle of data here. The user is going to interact with the application is going to interact with the operating system, and the hardware is going to interact with the operating system, application back to the user. All right. In a nutshell, that is operating system theory. A couple other core concepts is BIOS and UEFI. What does it do if it doesn't see an operating system? It just sits there, okay? And that's what you saw with my EFI. It just came up, and I would not be able to do anything. It would just sit there with that menu saying, I can't find the operating system. What do you want me to do, stupid user, right? BIOS will come back with say no operating system found. Okay, I'll just give you an error for that. So, and then what that means is either the operating system got wiped from storage, or the boot sector is incorrectly recorded. It can't find the operating system, that kind of thing. All right, so that will cover it, and I'll see you around.